I want from you guys need to explain to me what is that architecture and how do you explain it basically. So if you are able to explain that basically you need to tell what is that use case and what kind of structure they have used, what components they have used. All these things you need to explain to me, so that the other guys can ask the questions. So I got some reference architectures for you guys, and the naming will be there, and you need to tell which domain it is, what exactly it is doing and everything. So this would be a little complicated, but if you can explain this, what exactly each and every particular thing is doing, how they developed it and everything, this is the same thing you can explain in your interviews. So this is a pretty good I think this would be in until now what we have done, all these things were oral. Orally we have done it, we are discussing about the points and everything, but the whole point is when you go for an interview or something, the interviewed would expect what kind of architecture you have developed and how you have implemented it, what is the reason you have selected. So this architecture would help you basically. The first thing is how to build the architectures. Basically you need to create, if you want to portray that you are a solution architect or something, you need to be aware of constructing these architectures for sure, and you need to be aware of that, how we can create it. So we have a lot of available tools like Visio. You need to be aware Microsoft Visio will be used for creating these kind of things. And there is also a AWS, from AWS end there is a ARM IO watch which will help us to create these reference architectures, where you can select whether you need a VPC, whether you need anything, you can select it. So hopefully I think we can start the session. Rest of the guys will join. So this is the first thing I would like to present, this architecture. So someone has to take it and explain me what it is. Once you explain me, I will also explain the whole things with steps.
Okay, who wants to take a crack at explaining what architecture looks like?
What exactly it is doing, what it is they are using. You have a title here, you can read this. If you are able to get that, tell me which domain it belongs to, what exactly they are trying to do, and what exactly the components are, what they are trying to do, why they are using particular to that service, what exactly it will do. You know all the services, or you are not aware of any services, those all things. I think I would select the people. If you are not talking, definitely I should select the guys. So I would like to go with Mufti. Mufti. Yeah. Am I audible, guys? Am I connected?
Yes, you are.
Yeah.
Give me a couple of seconds to take a look at it. Thank you.
Good morning. Good morning, guys. Hello.
Yeah.
So please, while he's looking, can you just give us a brief, brief me about it?
Sorry, I didn't get you.
So I just want to, what's that document, that architecture, please?
Here it is there. I'm asking you guys basically what you understand with this from the architecture. If I tell that, it's no point to ask, right?
Oh, okay. Yeah, because I just got in the meeting. So, all right. So you are asking what is the document? What's that kind of? You are
So
asking us.
basically, what I'm asking is, explain me this architecture, what exactly they are doing. You have a title here, you have some information here, you have a lot of services here. So you need to tell me what is happening, why this architecture is.
Okay.
So in this architecture, we have yeah, we have if I start with the number one, um, I think it's a site processing zone. Okay, that's better. Yeah, site processing zone. AWS Outpost local processing. And I mean, if I understand, here is in the local processing and tool. So I believe that that's what they do all the process, all the data, and S3 upload, AWS start connected. So here they are also working with the S3, Amazon EMR, data quality check over the air engine. Building
You guys are familiar with autonomous driving, right? You have vehicles with autonomous driving, basically. Those use MD4, MDF4, and ROSBAG, right? You know, advanced driver assistance in these Google cars, Tesla cars, how they work and how they do automated cars. You guys are aware of it?
No.
Not really.
So basically, this we are building like a, it's a, so basically this is a architecture for a, basically for a driver, advanced driver assistance. So it need to collect all the details from car. It need to collect the details from the car, and it need to process it, and it need to provide the information back to the car. Advanced driver assistance systems. You need to like basically when it is an automated car or something, it need to get all the essential details, right? So it need to collect the details, how the car, how the car is performing, all the data management for autonomous driving. Okay, all the all the data management which we needed for autonomous driving development. So basically those are the thing, those are the important thing, right? So these autonomous cars, what they will do is they are currently the face of the transportations. So basically what is happening here is you need to process all the data which is coming from this car, and you need to have some KPIs which are important. So that basically you need to show those KPIs in order to approve that what kind of data it will collect, what exactly, make sure the all the car sensors should work. Basically the autonomous cars need to work, all you will have a lot of sensors in the car, and all those sensors will collect a telemetry about how the car is functioning, or how the torque power is, all these things. And it will use a artificial intelligence and machine learning to read all these specialized automotive files which are created from these sensors, which is called as ROSBAG. The automotive files are named as ROSBAG, MDFR, ADTF. So these are created by some proprietary software, and they would be collected in a single workstations. So these basically, when you read these MD4 or MDF4 or ROSBAG data, you read them, you analyze the complex and multi-field file structures, and by reading all these techniques, you leverage all the AI and machine learning, and you will scale the workflow to process the data so that it will be helpful. It will be helpful for the autonomous learning. So you run all the data analysis. So that's the whole thing. All the big car companies were doing this. So how to collect those details from a car, which is self-driving car or anything you consider like this, it have a lot of sensors. So all the data is being collected. Now this is the scenario of this architecture. So now if you can explain, anyone can explain this. Now you got the whole point. So we are creating a pipeline to collect all the data. Basically that the data can come from the car sensors, or else there would be some MDF like MDF4 processing tools or something. From there also you will get it. There are also customer facility station zones. From there also your data will come.
Okay.
So it's a self-driving car concept.
Yeah.
Okay, so I can see there's it collecting at the phase 1, collecting in the car the data, and at the phase, let us say 10, it has to store it in the S3 bucket. And yeah,
What how is it sending the message? So start from the uh the stage 1, and then talk
Yeah.
about the tools. Like what is he doing? What is he using? So
Mhm. Yeah, on the for the step, I would just want to make sure that I'm in the like
yeah, step
the
1,
beginning and the end first.
yeah,
And okay,
but then go through the tools. Like you see, you missed the step before it goes to the S3 bucket. So kind of walk through the workflow.
yeah, okay, yeah. And from the car, yeah, you use the direct connect here to connect from the on-premise to the cloud.
Mm-hmm.
Okay. Okay.
And where's the information being stored? Once he sends it to the cloud, where's the first step? Step 2 is what?
Yeah, the step 2, oven in the that's the tools I never use, but yeah, I know Amazon Kinesis, data file host. Yeah, okay, oven over the year ingest, IoT core, Amazon Kinesis.
I remember. Remember I talked to. Did we talk about? No, I forgot the class. Internet of Things. What is Internet of Things? In step 2 over there, see AWS IoT. When you say Internet of Things,
Yeah. Main guys, mostly I want you to go with all the things, the acronyms of IoT, what SDK is, what exactly it is doing. You guys need to explain it. If you know, so basically, if I am the guy, I will tell here. So basically, we have Ignite. We are trying to ingest the data from the on-premises using a AWS Outpost to S3 bucket. As it is in on-premises, I would like to collect my data from on-premises to my AWS cloud with the help of AWS Direct Connect, which will help us to transfer the data very faster as you have a direct connect. And as well as I also have an option, other than collecting it from the processing zone, I also have a data which is coming from the IoT, which is green gas or IoT SDK, which was set up in my car. There I am getting the telemetry data. I am ingesting the data. I am ingesting the data into in that data, bringing it from to S3 bucket. But in that layer, what I am trying to do. So basically, what I am trying to do is the data which come from the vehicle, the telemetry data, it's in real time because it changes every minute. If you're driving car, there would be 12 sensors in the car which would be sending the data, and you don't store the data, because if you are traveling like 600 miles, and if you are storing all that information in your car rather than having a petrol tank or something, you need to have a storage, data storage equipment, like you need to have hard disks complete with your car. So you need to do a real time processing of the data. So we are using IoT core, IoT core is one of the thing which will be help to read this data. So this IoT core will collect the data over the air ingest, and it will now the real-time data need to be analyzed. The real-time data, if you want to analyze real-time analysis data, Amazon Kinesis you will have. In the Amazon Kinesis also you have a lot of flavors, and that I am using data firehouse. And once the data is analyzed, that data I'm storing it in Amazon S3, because I don't want to store it in any I want to store it in a efficient buckets. I'm storing it in Amazon S3. Once I store it in Amazon S3, what I'm doing is I need to make sure that this is all raw data. This raw data need to be transformed. So remove and transform low quality data. So what I'm trying to do, I'm using a EMR. It is called Elastic Map Reduce, which is the other form of Hadoop technology, where I am using a data quality check. Data quality check means what it is doing, it is trying to remove the data which is not qualitative and transform the low quality data. Okay, that's what I'm doing. And whatever the low quality data is there, I'm putting it into another Amazon S3, because this data I could not use anything. The data which is transformed and which is in right form, right data, it is transferred to another S3, where we are saying that this is the exact MDF4 data, or ROSBAC data, or automotive file data, which is very important. That adding the labels, I am keeping it, and again I will process it. Again I'm processing it with another EMR process. Before talking this stuff, third step, I have a fourth step. Fourth step is nothing but Apache Airflow. Apache Airflow and orchestration. This is something which is used for scheduling. So basically, once you are doing this processing of data, here you would have a lot of workflows, right? These workflows all has to run at specific times. 8 o'clock at one thing has to run, 9 o'clock night, the data which is coming through that, immediately it needs to fall into that workflow, and it has to run a workflow at 8 o'clock, at 8:30 one workflow, at 8:45 one workflow, at 9 o'clock one workflow, to schedule the extract, transform, load, all the ETL jobs need to be scheduled, right? For that we would be using a Apache Airflow, which is a not a AWS thing. Airflow is a schedule it's a software which is used for scheduling. And now what I'm doing here, I have kept the data in S3 which was parsed. That was done. What I'm doing, I collected all the data which collected through these data, and I'm doing a enrichment of based on weather and map data. And again I'm putting that data which I got finally, that into another S3 bucket. Okay, I'm storing it into another S3 bucket. So basically what is happening, when the extract is running here, I have a Amazon EKS. What is Amazon EKS?
Uh, Elastic, I think no, it's not Kubernetes.
Amazon Kubernetes services.
Yeah, so why we are using this is, here also we have some data which is coming. That data need to be processed, like extracting the metadata, and you want to store the data, like whatever data here we are store, like Kubernetes will take the data and process it. It need to be parsed into DynamoDB. And from the DynamoDB, what I will do is, I have a like when I store the data here, I don't want to query the data. If I want to search the metadata, if I want to do a continuous search, like if you want to do a GPS search or something, you don't query it, you do a search. So for that I am using electronic search service, and I have a Neptune data language, Amazon Neptune data language. What is this Neptune data language? This is a graph database to find the hierarchies, and I am using a AWS Glue data. AWS Glue is, what is AWS Glue? Have you heard about AWS Glue? It's a data catalog. So AWS Glues are for data catalog, for doing all the search and these things. Your data need to be like you need to do a binary search on it, all these things. You will use AWS Glue data. So what you are doing, you would be storing all the data lineage in Amazon Neptune or Amazon Glue data, so that the processing can be done. All the process, so all the processed data, all the process drive data and perform like basically they were getting performed in another Kubernetes service. Why we are not using the same Kubernetes service? If you see here, I'm using multiple S3 buckets, multiple EMRs, and multiple EKSs. So the whole point here is we are making sure that in our architecture we are not waiting for the same EMR to it. We are spinning other EMR and we are using it. We are using multiple services. So the data is totally performed, and the complete processed data is in, like it's like a stage data, it's like production data, it's like test data, what you keep it. So the S3 buckets work like it. So finally what all data you get it, you will be performing a automated labeling uh, using Amazon SageMaker. Amazon SageMaker is also one of the thing which will be used for like basically to recognize the data, and you want to do artificial intelligence on the clock, the on fly with the data, then you will be using a Amazon SageMaker, which perform automated labeling using Amazon SageMaker annotation. So then that data will be provided to the users, and the same data whatever we have done, we will put it in Amazon S3. We'll put it in Amazon S3. This data again will be dumped into Amazon catalog data, where users can do a search from the interface and they can see the data, or else they will be provided with the information they need directly on the go. They can search it, or it will be displayed in their navigation screens. So this is what the architecture here. So why we decided, like the base reason for this architecture is basically what is the main goal is how we are processing all the data which we need it. So this is called as data lake. So this is an example for data lake. So which is a single source of truth. In a lot of companies you will have an enterprise data lakes. So like basically if you are architect, they might ask you a question whether you have built any enterprise data lake or anything. So you can give some of the examples, like yeah, we used to collect the data and we used to process it. The data, see, the whole process of data lake is I used to collect data from the source system, from the on premises. I used to collect all the, like I used to get the data in the form of JSON, because in the JSON form it's like whatever like if you have a high amount of data also in the JSON form, you can keep it. So I used to collect the data into S3. From S3 I used to parse the data from S3 into some other source, either Amazon DynamoDB, or else some uh, Oracle database or Amazon Redshift, anything you can choose it. But whether you are doing a transformation of data, how you are doing the transformation of data, I used a Python programming to transform from the JSON. I need to I need to pick the data, I need to separate the data, and I need to store it into some database that can be Snowflake data. Let's say is it is a Snowflake. So I collected all the data, I parsed the data from JSON, and I kept it into staging staging pre-staging in Snowflake. Then from the Snowflake, I used to collect the data. I used to run a ETL job where another Python program runs, and it will transform all the data and it will create tables in the Snowflake, which is the staging channel. And from the staging, it will go to the next chain, and the whole data can be, if users need the raw data itself, they can connect to S3 bucket. If users want it for reporting, they can connect to Snowflake and they can use it. So that's the way we need to explain the enterprise data lakes. And this is one example of enterprise data lake. People have a misconception that we would be using only one service at one time. No, we can use multiple services. You can have a number of S3 buckets. You basically the naming what you do and how do you use it, that's the most important thing which we need to see. Any questions in this? If anyone have any questions in this, you can ask.
So I have a question, sir. So this data lake, is it only used for self-driving cars, or they can use it for other program or system?
The same architecture, you can't use it. Basically, if you don't have the data, like basically it's for the automation based companies and the vehicle based companies. Like if you are working from for some companies like Aptiv, or Bench or BMW, these companies might need these kind of data. Like that's what I'm saying.
Okay.
Based on the domain, it gets changed. And also you need to ask the question where they have the data, where the data is coming from. If the data is not coming from this like they don't have a site processing zone of ROSBAG or MDAF, then definitely your architecture might change, because you need to think about it. But the whole point is you need to see, when you build a data lake, the most important thing is ingest the data, store the data, process the data, and provide the data to the customers. So these are the four things which you do: ingest, store, process, analyze, reporting. So these are the five purposes which we use for enterprise data. So you need to say all these five things connected, what services you are using. Okay.
Okay, thank you.
And I want to let me add something regarding data lakes, right? You can use data lakes, like you said. It doesn't have to be just for automating cars, right? A data lake can be used whenever you need to ingest, process, store, and then report on data. So it can be for, it's not just for a car. Anything that any work you do and that has to do those things. You can use like a data lake concept. So this one is specific to this automation, car automation. But again, if it's another project, like let's say it's like you want like a kind of a warehouse where they need to pull some data and process it. And you can use data lake for different scenarios. I just want to make that clear, so you don't feel like it's only for automated car. It has to do with anytime you're collecting data, you're ingesting data, you're processing data, and then you have to report data. A data lake can be applied in that concept.
So
Okay, thank you.
I have another question. Like as I explained all the things, now someone explain me what is a data lake. As I discussed about the architecture of data lake. So what is data lake now? Can anyone tell me what is data lake?
The data lake is the process where you collect data, you analyze the data, and then you use it for customers.
Okay.
Like,
So
I
I
just
would give
wanna.
a small, I would give you like this. So basically data lake, as I mentioned, it would be a single source of truth. So what is the purpose of developing a enterprise? So most of the companies will be talking as EDL, enterprise data lake, or enterprise data platform. The reason to build these enterprise data platforms is, in every company, in every organization, in any industry, what happens is they might be using a lot of different databases. In some team they are using SQL, in some team they are using Oracle, in some team they are using NoSQL, Cassandra, in some teams they are using some big data. Okay, like this. They now what will happen is, in overall company there are several resources, several sources of connecting to data and analyzing it. This will become a problem, because as a business user, if you are a technical user, you are good with it. But when your business users wants to connect the data, he would be pissed off, because there would be several environments. He need to collect the data from there, and he need to basically from different disparate data sources it will be, and he need to blend the data. This is all two technical things. That's the reason these enterprise data lakes came into existence. Data lakes are like, if you are in on premises, we call them as data warehouses. Now in cloud terminology, we are calling it as enterprise data lakes or enterprise data platforms. So these data lakes are nothing but, it's a storage repository which holds a vast amount of raw data, which holds a vast amount of raw data in its native format, in its the format where how it is coming into the source systems, that format, including it can be structured, semi-structured, unstructured, any data, anything. The data structure and requirements are not defined until the data is needed by the customer. That means you don't process the data without the need of the users. You keep all the data over in S3 buckets. If user wants it, it'll connect it. Based on the user requirement, you will construct some of the tables and you will provide it. Until that is, the data structure and requirements are not defined until the data is needed. So why you should care about this data is basically the reason they are doing is they want to make sure that they 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 want to make sure that the structural silos, these things should not come into department. Basically some team will have a requirement, I want uh, xyz table, xyz columns. Some team will say I want abc columns. Some team will say I want abc and xyz. So that's the reason we don't define the tables previously itself. Based on the requirement, we might create it, or we'll give the source data itself. So that's the main thing. So basically why we are doing this, this would give a self-service. This would give a self-service, more self-service for the users. And the physical storages also, you don't need to have so many physical storages. You can use a lightweight processed data, and you have a exceptional scalability, high durabilities. All the unstructured and all these data can be there in the databases. That's the most important thing. Okay.
Okay.
Right, I have a
If,
question.
if I may add, Farmer, just before you ask, right?
Okay.
So think of a data lake like the name itself tells you, right? It's like a lake that holds a lot of. You should think about water. It's like a lake that holds all the critical information that you need, right? But how you're gonna drink that water depends on you. How you gonna you can ingest the water from a lake. So the source is all the
I'll have
data
to filter the water.
is put there. So you can filter the report, see how you want to see it based on what you need. You can drink as much of that as you need. You can take only a few sips. So that kind of, in a visual aspect, that's why they call it like a data lake. It's a place where all the data that you need is there. So when you need it, how you need it, the columns, how you can pull it from that. So that's another way to just like memorize like kind of what it is. Okay.
Okay, I have a question, Tara. I just want to try to visualize it based on the architect, like what can be like a real life scenario. What about you see those Apple Watch or those Fitbits?
Sorry.
The Fitbits or Apple Watches, and can you use that concept with the data lakes to
Yeah,
be
the
able
same
to?
concept. The same
So to
architecture can be used
extract.
for Fitbits.
Okay, so you're gonna extract all the information for customers, and then they can either have it if they want information based on their own. They can retract it. They can retrieve it based on the architecture.
Yeah,
Yes, I was just
Fitbit is
trying to.
using this kind of architecture, not same exact services, but it's a kind of similar architectures. It will be collecting from the device. Mostly it will be collecting from the device, all the telemetry, and it will have a IoT connected to it. It will pass the data. They can use Amazon Kinesis or anything other than that. They will have a central station also, like people who would be updating their data in the form into app that will be stored into some other processing zones. From there also you need to collect the data. Based on the two datas, you need to do it.
Okay, thank
Yeah,
you.
that's how it will. Okay.
I have a question, please.
Yeah.
So if I'm as a solution architect, at which level that design is requested? So it's like a high level design documentation that you have to provide to your customer or to your client after doing a requirement gathering and try to provide a solution to the client.
Yeah, yeah,
or is
the high level, completely high level. You need to have a complete architecture. What is happening? Yeah, as a solution
Mhm.
architect, you need to do all the things. It should be a high level and low level documents when the requirements are collected, and you need to also do a POC. It's not only presenting to them. You need to do your POC on your POC before implementing that. You need to have a prototype. What kind of technology you are using, what kind of service you are using, how it is being processed, how it is being done, and everything you have to show it in them, like how you are enabling them, how fast it is done, doing everything you need to show. You need to have a document, you need to have an architecture design, architecture template, and you need to also have a prototype.
okay. Okay. Thank you.
Mm, yeah, this is another thing which is from transportations and logistics data lake. So basically, this is also a data lake. If you see the difference between the data lake and this data lake is completely different. It's completely different. It's not. So I just want to show you that you don't remember anything. It's not like remembering some data architecture and going. It's different based on the domain you work it. So this is for transportation and logistics. So let's think about a company you consider it like a Amazon portal itself. Okay, it has a transportation and logistics also need to be taken care. So they have a lot of aspects like a Amazon.com. If we take Amazon.com as an example, so you need to consider all these important things from where the data comes. So the data comes from IoT devices, from third party providers, traffic, weather also they need to take in consideration. Because what if generally they say that the shipping will happen in 2 days. What if there is some natural calamity happen in this region where the shipping has to be done? So they need to predict that. Based on that, they need to prioritize those orders and all those things, right? So all those things need to be covered. Booking portal you have done it already. The data is all this historical data is there. Where are third party ERPs? All the big companies will have ERP systems like SAP and everything. You need to collect the data, because in the SAP system, the order processing, order data, all the data will be transactional data, everything will be stored there, and the data will be coming. Okay, see, and you also have a mobile apps data. So all this data, taking into consideration, this architecture was built. So there is a ingestion layer. So basically this is what I'm saying. There is a ingestion layer, there is a ETL layer, there is a data lake, and this is a client layer. So basically, people like when customer doesn't bother about all these things, what is happening. He would see only in the client layer whether he was able to use all the data what he needs to do a business, and whether he can use a QuickSight, Tableau, Power BI, Amazon Redshift, Amazon Athena he wants to use it, or he wants to use a Neptune, what he wants to use. So a client layer, he wants to do analytics and business intelligence, he wants to do a predictive perspective, machine learning, he wants to do a blockchain, he wants to build some databases, he wants to do some reporting. That's all depends on the client layer. So this is what client layer. So ingestion layer is the most important thing, because before getting the data into the data lake, so the data lake can S3 also can be a data lake. Your S3 also can be a data lake. Your Amazon Redshift also can be used as a data lake. Your database can be used as a data lake. It's not like that only S3 is a data lake or anything. Wherever you have all the raw data, where you have all the raw data, raw data which can be used by the users, that's called as a S3 data. In some companies, the processor data also can be called as process data also can be called as data lake. So you need to be careful of explaining. So here, if you look at this data here, whatever they are doing, enable transparent and logistics company to break data silos and create a single repository from the data from multiple locations, and scalable architectures removes the complexity and costs of managing and synchronizing on-premises databases and its estimated business. So that's what he did. So basically what he did here, so here he have a lot of On premises, he has a lot of tools, right? So basically in the same way in Amazon A3, what he is doing, he created location data, POs, bills of landing, SL costs, freight costs, freight rates, free trades, tenders and bids, capacity, what is traffic, what is weather, IoT data, equipment fleet data, bookings, mobile data. Like this, he created all the buckets, okay, all the buckets. Now user would like to connect to bills of landing. He will come and connect to this particular bucket, and he will analyze the data, whether he want to transform this raw data into any database or anything. He will decide. He will build a graph data, he will build a Amazon Dynamo database, he would like to use Amazon Error, he can use it. Basically from here also he is using Lambda. So basically what he is doing here also, he is creating an event to load the data, load the data from S3 to any of the particular services what he needed. Got it? And here if you see, here what is happening. So basically what happens when you have a data, when you have data in on premises things, if you want to transfer with direct connect, it will cost you a lot. Like if your data is more and everything, and if you want to transfer, you can't transfer the data through internet, because internet costs are very high to do data transfers. There you need a lot of bandwidth and everything. So that's the reason when you want to transfer the data from the on premises to the cloud, then you need to use AWS have a component called a Snowball. So it will send a device to your company where you can send the data ingest into it, and it will have an encryption layer. So you can, from the AWS Snowball, you can collect. Or if you see that there are some booking portals and everything, the data automatically can be transferred into cloud by using AWS Direct Connect. Or you can also have, there are SFTP protocols. Amazon also, AWS also have a transfer for SFT. You can use file transfer methods. Those are called as file transfer. When it is coming from a mobile device or mobile devices, then you can use Cognito, AppSync or anything, Cognitos or AppSync. See, I can use Amazon Cognito or AppSync so that the data can be connected from these things. So, and if you have any data from IoT devices, if you are getting the devices, let's say you have Amazon Snowball, okay, Amazon Snowball will have sensors, because Amazon Snowball is a big truck which would be going to the industry and it will be collecting. So it need to collect all the data, whether anything, where any breakdown was happened, what is happening, to collect all the data IoT device. There is a using a core. This is a real time streaming analysis. So that would be ingestion layer. This is all ingestion layer. When you are getting data from IoT devices, I am using AWS IoT core, Kinesis data streams to stream the data. I am using the Kinesis data streams to stream the data and parse it into Amazon data warehouse, and I'm storing it in Amazon S3. When the data is coming from AWS Snowball, I will get the data from Snowball and I can keep it in the database migration service. From there, the data can be transferred into S3. When it is coming from Direct Connect, I can use AWS Data Sync and I will put the data into S3 bucket. In the same way when it is coming from file transfers, I'm putting the data into S3. Now the here form main thing is ETL layer. When I have a ETL layer, here I would think whatever S3 raw data I have, that raw data, what I'm doing, I am not doing a complete ETL. I am doing a AWS lake formation. That means all the data coming from all the devices is getting stored in one bucket. Now I need to segregate it. HR data, logistics data, transportation data, weather data, employees data, employee salary data, all these data need to be divided into different tables. You will have different tables in relational database. But here what I'm doing, I selected buckets because S3 is very cheap. So I selected S3 buckets. So here I am using a AWS lake formation. AWS lake formation, like you can use AWS lake formation services, and here it is transforming the data and it is putting the data into buckets. That all the from here, the bucket, from a single bucket, it is processing the data and dividing it into different buckets which it falls into it. Here you would have a code logic. And here, what you are doing, you know that there are some certified data sources which are already getting used in on premises. There are some predefined data sources which would be widely used by all the people in the organization. On premises, they are there. There are some 100 tables. All those data layers, you would have a data catalog. Basically, that is a data catalog, what you need it and everything. That all data transformation, you will do it and you will keep it in the data catalog. And the glue will be used as a catalog. Okay, glue will be used as a catalog, and you will have a EMR where which process the data, that process that already tables, already predefined tables or anything which was already used in on premises, that are processed. Those were in there in EMR. Those were there in EMR. So this here in this data catalog, it will be there, and users can connect to this data for reporting, or they want to process more table and refine them into tables. They can use Amazon Redshift or anything, or they want to store some data, they would be using Amazon Redshift. And they have a crawler here which will help to form the data catalog on the catalogs here. So here, why they are using a Lambda and everything here is, whatever data is coming from the mobile web services or something, it might not be a continuous traffic or something. When some traffic comes to App Cognito or AppSync, immediately it will trigger this data need to be transferred to uh, uh, S3 bucket or AWS Lake Formation to put it into right buckets. You would use a Lambda and you will process the data on the fly itself, and you will put it into AWS Lake Formation, and it will transform the data into S3 buckets. From here also, we have a Lambda which is triggering. So basically, Lambda job, what this Lambda activity will do. So basically, whether the client needs the data in ML, so the Lambda will trigger it, and the data will be transformed into the ML services. Or else he can need, if he need, the client layer is, for example, they are not this doesn't mean they are using all these things. They can use any one of this. That's the main thing basically. Any questions here?
Please, if you don't mind, what is the Amazon SageMaker?
So Amazon SageMaker is a like a machine learning tool. Basically, there are Amazon devices also. Basically, particularly, I don't know. This is called as, you would have basically some tools. Amazon and SageMaker also have some exceptional camera which will recognize. So it's a fully managed service by AWS. Basically, every like data developers or data scientists, they can train the model. They can train the model. They can build it, and they can deploy machine learning models quickly. So SageMaker will remove the heavy lifting from each step of the machine learning. Basically, SageMaker will help us, like if you need high processing machines or something to process all the data which is coming from uh, those machines, that SageMaker will help. More, if
Eh,
you remember or
Yeah,
not, when we
yeah,
went to AWS conference, we
yeah, they
went
gave
to
us a
this
camera.
particular session. We got the cameras which is used for SageMaker to capture and identify the data and transform that idea. So that if you show, if you see, this Amazon SageMaker will be there for most of the phones. When you take a photo for a photo, when you're trying to take a photo, it will show the age of the person, right? It will show the person says. If you go to any shopping market, sometimes if you take a scan the barcode or something, it will show the price. So those all things will be done by this Amazon SageMaker. Mo, if you remember, we have done that particular course when we got the cameras also for that
Yeah.
free for doing that course.
So
Yeah.
so basically, like they gave us this smart camera, this intelligent camera, and then we had to see like it would, you show the hot dog, and after you show the hot dog, it will start to learn. So whenever it sees a hot dog, it will say this is 95% chance this is a hot dog. So what it does is, the more it sees the object, it gets smarter to recognize it. So this is what AI does. So SageMaker is the tool that processes, helps to learn. So the camera it can whenever it sees, the camera sees like a hot dog, it's that tool that processes to get smarter. So SageMaker is a powerful tool. So it works with the camera. So the camera can learn. So whenever it sees a hot dog or it sees a chair or sees somebody's face, it recognizes your face. You know, it's similar technology that's being used for, like, you know, your facial recognition for your phones and stuff like that, where it can remember the features to see that if this is you, if it sees you, it knows who you are. So it's a machine learning smart, but it will pick up on images and do that. So when you go to the airport or when they're finding people's faces, SageMaker is one of those tools that can process the images that are being collected from the camera and try to learn from identifying you.
And
So
the
so
SageMaker
basic.
technology is also can be used in vehicle to vehicle transfer speed, how much this Tesla cars and the automated cars. What happens is it calculates the car before the car which is going in front, which is going beside, which is going beside, which is going at backward, when we should push the brake, how fast we can push the brake. Automatically it calculates the speed between those cars and the distance between these cars, and how frequent, how faster I can pick the car, how should I turn to left, should I turn to right. All this will be captured by the sensors and the cameras, and it will calculate that speed on the fly. So there the SageMaker will be used.
So they are like artificial intelligence then,
Yes.
stuff like that.
Yes.
So so I think that's what is that what they use for, like the Amazon Go?
Amazon Go.
Yeah, Amazon Go is like the grocery, the Amazon grocery store where you don't, that they don't have like a cashier. You just go in
So
and
you're
then
right,
you grab
Amazon
stuff
Go.
and you.
Yes.
Okay.
Yes, you're right. It will identify what like basically when you keep it in your basket, it will automatically recognize that product it is, and it will do all
Correct.
its billing and everything. So
Correct.
it's all like capturing the sensitive points. We train our models in such a way. So Lambda will trigger the data. Amazon SageMaker will perform the data. Let's say how many chances we have that the placed orders can be cancelled. So that's the question from the CEO. So there a machine learning need to be done, a model need to be trained, and say that if 3 orders were cancelled in a day, we have a huge based on our model, we can say that in a year there can be 365 cancels, 365 orders can be cancelled, and this was the revenue we can lost from it. So that kind of thing, like what is our attrition ratio this year, what can be our attrition ratio. So based on that they can improve their business. So the machine learning, the ML can be used in different ways. Okay, any questions?
I have a question.
Yeah.
On the client layer, we have two AWS Lambdas. Why two? Can we use one to trigger what we need to all these components?
It need to do the, see, basically you can't do the sequential work. You don't know that the data will be triggered only for blockchain ledger, and there is a request from purpose built databases. He need to wait until this job is completed. Lambda, it's not like that, right? That's what I said. You don't need a one service over there. It should not do a sequential job. It should, like, basically your work need to be done in parallelly, right? if i'm if I'm running a taxi service, Mo has came to me and he has said that I need a car to go to New York. I said, okay, you take the car and go. The second person came and said that I need a car to go to Texas. Then I will say, you wait until Mo comes to me, because Mo has taken my car. So you wait until he comes. He will take 10 days. He will stay with me. So that's the whole point. That's the reason I have two services here.
And also I have another question. So this data, how long does it take to be processed from A to Z? For example, where in the previous architecture, if a car is driving 60 miles an hour and the other car is driving, let's say 70 miles an hour, and in a matter of seconds, you can have an accident if the driver or the auto driver doesn't react quickly. So for this to go all to be processed and get a response and tell the car to make a right or left to avoid the accident. So how fast does this get processed?
It will be done in milliseconds. For sure. So this question I can't say. Basically, I can't say this answer how fast this whole thing, how fast it would process. What is the amount of data? What is the volume of the data? What is the variety of the data? These many questions are there still, but it happens. All these operations will happen. All these operation will happen in basically in fraction of seconds. It won't take milliseconds, not seconds also. Less than milliseconds it might happen. So I can't give you definitely the number, because we are seeing it in live, like all the radar aeroplane, like all the aerodromes and everything. You have a radar segments, right? How fast it is collecting the data and how fast it is processing. Those are the live examples what I can say it. And but I can't give you numbers. No one will ask you like it's not a math calculation that this amount of 4 GB of data is there, how much time it will take process. If I use high processing machine, it might take less than a millisecond to process the data. So it's all depends on the kind of instances what you use, bare metal, the P4, those all depends on that. And I can't answer the question what you have asked, because it's completely undefinable, but it happens in a millisecond. That's the answer.
Yeah, I just wanted a general answer, like how, is it fast or does it take long
It's a
time?
faster.
But yeah,
See,
it is fast. So you
if it
answered
is
the
not
question.
faster, Tesla won't use it. Tesla, all the Tesla cars should have been banned by now if it doesn't happen, right? All Tesla cars are the automated cars. They are going. You know, the Google car was not successful, but the Tesla was successful, right? For the automated drive and everything. So it's the thing, main thing. And your GPS is one of the your navigation devices are one of the other examples where you have in your cars. Your navigation, you are traveling and it says that you are moving. You have to reach it in 150 meters, 120 meters. How it is calculating? That's a live example.
Yeah, thank you.
Any other questions? No questions? Okay, that's good. We already discussed this. So this is another thing which you can explain me. What is this one? And you can explain this guys to me basically. This is also one important thing. So enterprise data infrastructure on AWS. So what by looking at this picture, what do you understand everything? Look at this picture. If it is not clear, I will reduce it a bit. So now you are able to see the complete one, right? So look at the architecture and explain me what exactly it is talking about. And you should be aware of these symbols and these things. What is the symbol defines? It's particularly talking about a OSS soft. What is that? You you look into this architecture. I'll be back in a minute. Someone is ringing my bell. Guys, back. Got it? What is this example and what they are talking about? What those pictures are? This architecture, you guys can explain me. It's not a too complicated one. It's a very easy architecture. Generally, when you design it in the industry for any application or something, this would be the architecture which you would be using mostly. You guys know about OSA Soft? Have you heard about that company OSA Soft? It's a very popular one in California. It is located in. Have you guys know about this OSA Soft? What it is?
No,
Sorry, someone
no.
else. It's a real-time data management called. They have its own called as PA systems. They have their own PA systems, which will help us. Like basically, they have a different kind of products. They analyze the seasonal trends. They determine utilities are meeting for the demands of production. They will compare the performance of different lots of raw materials. All these things they will do, or they will optimize the utilization and the performance of a production line. So they have a pi data, they have a pi data archive, specifically they have a pi asset framework, they have a pi process bank, they have pi data link, pi web api. These all are their own let's say their own kind of products. Pi vision, like they have their own tools, you can say, those kind of things which they are using. So basically what they are doing, they are migrating their whole making sure that whatever they have it in on premises, they are they want to implement it into the cloud. So basically what they are doing, they have on premises, they have a PA interface, PA servers. Okay, so they're building in cloud. What they need, they made sure that they should have high availability. So they have availability zone 2, they have two availability zones which they have identified, and they have a VPC. So basically in the VPC, they have some public subnets. They have a one public subnet. In one public subnet, they have PI connector, PI web API, PI vision. And in other public subnet, they have different one, and they have some private subnets where they kept some of the replicas of the databases and those things. So basically what they are doing is, for everything they have a VPN connection from on premises to this, and they have a direct connect, and they are collecting all the data and they are transforming in this. So basically this PI connector relay and all these things, these can be installed on a EC2 instances. They can install it on EC2 instances or anything. So if you look at this explanation, so basically what he is saying is the point one, let's see. Hmm. The point one, PI system connector connects PI system from individual sites to the roll-up PI system on AWS via AWS Connect or AWS site-to-site VPN. So from here, it connects on premises and AWS Cloud with AWS Direct Connect. So IoT green device, what it is doing, basically whatever data they have it in their basically from edge devices or everything, it can be transferred through IoT core with a Lambda function. So AWS IoT or Greengrass, basically what they is doing, it's transforming all the data to the Lambda function. And that Lambda function, what it is doing is, it translates the data, it translates all the data from the messaging format from which is it is coming from the OSA soft. It sends to a web API. It sends to a PI web API. All this data can be transformed with a PI web API or something. It will take the data and it will have a connector relay. So these all things are specific to their business. This PI vision and PI connector relay, PI analytics, domain controllers, all these things are specific to the business of OSA soft. If you don't know that also, it's not a problem. It's not specific to know what is this PI vision, what is this PI connector relay, what is this PI web API. You don't need to know because it's specific for their business. Only things you need to know is how you are building a architecture which would be a high available. So that's the reason we have a public subnets. So that means what we are doing is, why we are keeping these APIs, connector relays and PI visions in public subnet, because people, anyone can connect to this. Private subnets, no one can connect, only the company people can connect. These are not open in the private connect. So here you have a database. So here you have a first primary database, here you have a secondary database, and how the traffic, like when a user connects, see in the user point, he would be connecting only to the public subnet. He never can connect to the private subnet. So he would be querying the API what is needed, and the API how it will contact to the private subnet. So basically the elastic load balancer, it will send a request. So first of all, a request came from the user to the elastic load balancer. Elastic load balancer will decide, okay, what is the request. Okay, he is asking for a web API. Then web API, it will go the request. Now the web API will check the request, okay, and it will say I need this request. Then it will go to elastic load balancer again, and elastic load balancer will trigger this SQL and collect the data, and it will give to web API, and this web API will give the response to the user. So acknowledgement, handshaking, everything will happen here. If inside the company, if you want to do any reporting, you can connect to the public subnet. The same thing for the end users also, from the customers also, you will give ability to connect to the public subnet, not to the these things will be there for only the administrators. Got it? So that's the whole setup I built. So basically, whenever you built a application, whenever you built a application, you built an application in cloud, you would make sure that the application servers and the database servers, and you would have web servers. So basically the web server would be interacting with the public internet, not the application server and the database. If you want to go, you need to go with a, you uh, basically you will not have internet traffic, cannot access the database server. It should go through web server, application server and database server. That's the architecture we should develop. Got it? So that's the more important thing. And you need to make sure that when you are having a failover or a fault tolerance or failover mechanism or high availability, you should make sure that you need to use multiple available zones to place different EC2 instances in different places. Got it? Any questions here? Any questions, guys?
So I'm assuming you all understand that, right? So out of all the ones we've done so far, this one should look the most familiar. This one,
Familiar.
yeah, most of the stuff we've been doing.
So basically, I am not sure if you guys are aware that we have a single tier, 3-tier and an entire architectures. So first of all, when you have an architecture in on-premises, you should see what tier architecture it is in on-premises. And when you are moving to cloud, you should define, okay, you should define basically that architecture, and you need to also decide what the architecture you would be developing in that. So 3-tier architecture is a software architecture pattern. Basically, generally a 3-tier architecture, or like when you don't have a efficient machines, you will use a single tier. But most of the places we use a 3-tier architecture. It's a general software architecture pattern where the applications are broke down into 3 logical tiers, which is the presentation layer, the business logic layer and the data storage layer. The same thing what I have said, application servers, web servers and data servers. So web servers is like basically application server is the thing which you called as business logic. Web servers are called as presentation layer. Databases are called data storage layer. So this architecture is used. So basically when you use a 3-tier architecture is, you use this architecture in a client server application, such as when you have a web applications which should have a front end and a back end as a database, then you will use each of these layers or tiers does a specific tasks. Like basically web servers would be doing to route the request, applications will do the processing of that request, data server will bring the data requested by that application. Got it? So application server, what application server will do? Authentication and authorization will be done by which server? Authentication and authorization will be done by application server, and access to the data will be provided by data server. Got it? Any questions here? Now you understand how you define your architectures. Do you have any questions on this architecture thing?
So when we building it, so we have to follow all those three layers, like
Yeah,
every time,
yeah,
all the time.
all the time it is key. Presentation layer, business, what is their business logic? So basically what you should expose to the end users, what you should expose it to the customers, where the business logic should be there, who should have the access to the business logic, who should have the access to the data. If you make your business logic to public, then it's done. You'll not have business next day because your business logic is out. Got it? You will not tell your business logic anyway. So that's there the security things comes into place. So if you remember or not what we discussed, when an architect, operations and security is the most important thing. So when you are applying or present a layer, if someone ask you a question, why you are not accessing to this particular layer private subnet, they should say our business logic and databases, business logic and basically my business logic and database logic is present, data storage logic is present in this layer, data store layer. I don't want to exhibit it to the customers. So that these would be the questions which will be asked in your interviews. So architectures also you can see three tier, what is a three tier architecture, what is the entire architecture, what is what kind of architectures you have it, those all things you can see it. Any questions do you have in this particular? We can discuss on this if you have any questions.
If you don't mind, can you please go over it one more time, if you don't mind? I mean, all the layers and
Okay,
everything.
so basically three tier architectures, what I said, those all are, this is a architecture pattern generally we use in software. This is the main thing. So when you build a e-commerce site, most of the IT companies will follow three tier architectures for any solution they build it. So when you build an analytics layer or a machine learning layer, they would have a entire architecture. Okay, entire architecture. In the traditional uses, we used to use single tier architecture. Two tier architecture no one will use because it's a most risky one. So the main the thing is when they in this architecture it was broken into three layers. First one is presentation layer, second one is business layer, third one is data storage layer. So these architectures were specially used in a client server application. That means a web application. Generally, when you use web applications, people will use this kind of architecture. Either you can call it as client server application. And in each of these applications, basically you will have one front end, which is used by the users, and a backend, which is database. So some people will ask whether you are working on a front end or a back end. That means if you are building some website that is front end, back end, what kind of database. So each of these layers, as I mentioned, basically they will be doing a particular task, and each task is independently managed by each layer. It is, so basically this is a big shift in all the IT companies from a generic way of building an application to the different layers, different ways. So in Amazon Web Services also, in Amazon Web Services also, basically we can build this kind of architects. So generally when we are building this three-tier cloud infrastructure. What we will be using, the main services, we will be using Elastic Cloud, Elastic Compute Cloud, EC2, auto scaling groups, virtual private cloud, Elastic Load Balancer, security groups, internet gateway. These would be the main components when you use when you build a entire three-tier architecture. EC2, auto scaling group, virtual private cloud, Elastic Load Balancer, security groups, and internet gateway. So these are the infrastructure generally people will use. If you ask me a question, can't we use another services? We can use other services also, but most of the cases, most of the architects, they will make sure that when they are building an entire architecture, they would have these services, so that they load balancer and these things. So basically what we are doing here, we are saying we are building a module kind of thing. That means if you have an issue, you don't need to completely look at all the things. Either you would go to a presentation layer, the problem would be at a one layer. This is called a module approach or modularization, you can say. That means you can focus on one tier, and you can quickly identify the where the issue is. And scalability, basically if you feel that there are too many data requests, then you can increase your databases. If you feel that too many users are coming, then you need to increase your web server. If there are too many authorization requests, then you need to increase your application layer. So that's the main thing, scalability and high availability. If your database is down, still they can access your front end. If your data layer is not active, it is down for some reason, still they will have access to the front end. That is called high availability. And as you spin it in different availability zones, you will have high. And the same thing, the fault tolerant machine. And security is the key thing, because people who have access to the front end, they doesn't directly, their request doesn't go to the data layers. It would has to go to the presentation layer, business logic, and then data servers. So there is no problem in security. Got it? So first of all, here, the first thing is what you should build in this architecture. When you want to when you want to develop, when you want to put it as a prototype, first of all, what you will start with and what you will work with. First, what should we do in this architecture? What you will build in this in this architecture? First, what you will create? First thing, what is the first thing you should create in this architecture? When I want to build this architecture in AWS Cloud Portal, what is the first step you would do?
So I think you start by creating an account, create a VPC in a region,
Okay.
and yeah, after the subnet in availability zone. So that's how you start.
Can you set the steps for me? Like basically, I need steps. What would be you doing? Let me know all the steps. What you would be doing? First of all, you will set up a VCP. Then
Yeah, VPC after subnet.
okay, fine.
Yes, in availability zone. After subnet, I can start create my EC2 instance.
Mm-hmm. Okay, carry on. You carry on. I'll again frame it.
Yeah,
Okay.
internet gateway. Mm, so put my security group in to protect my instance and update the knuckles too for security. Also, I can start the load balancer and auto scaling. After that, the RGS.
Okay.
The database. Yeah.
Okay, you covered pretty much points. So basically, what I would say is I will create a VPC. Then I'll go and create internet gateway. Then I would create my subnets. Then I would create my route tables. Then I would create my NAT gateways. Then I would create my security groups. Okay. Then, as you said, you can create your load balancer. Then You can create basically here also you can create your security patterns, security groups, and then next auto scaling group, and then you can create your RDS. So these are the steps you should say. So the people ask how you will create. Definitely interview will ask when you tell all these things how you will create. So basically you need to okay, you created all these things, but how you will get the action, how you will get the access to the all these EC2 instances or something which you created, how you will get the access, what should we have? You don't have access. We by default we blocked port 80. Sorry, port we cannot do RDP. How you can access it? So in order to access the EC2 machines, what you should have?
You can use you can SSH to your instance,
Sorry,
or
what you can do?
you can use a secure shell to access your instance.
So basically what I'm saying is you are blocked with the RDP and PuTTY and everything. So if you want
Okay.
to access that machine, like basically your RDP and PuTTY access were removed. If you want to connect to the machines, what you need to do? What you need to develop?
You give a user a programmatic access, programmatic credential, and use the Amazon CLI.
You don't have access, right? How you would providing it? That's my question.
You need a
Can't provide.
Bastion host.
Yeah, that's the point I'm asking. You need to have a jump host or a jump box using a Bastion host so that you can connect to the machine. And Bastion host you should mention, because the interviewer could have not mentioned it, but you should say in order to connect to the machines we also need to build a jump box or a Bastion host using a Bastion host. That's
And
the
guys,
important point.
yeah, good point. And we did it in class, right? You guys remember how do you communicate to a server that's not on the public subnet? You need a jump host where you log into a server that's already in that VPC, and from that VPC you connect to the server that's in the private subnet. We did that in class. I showed you guys how to do that, so you guys should be able to talk about that comfortably because that's something we did.
Okay, these are the important things which I think you should focus on this. And mm, these if you know all these things, it's pretty easy. Like definitely I think you can crack the interview. I think I also sent some of the questions. You can also look at those questions basically, which I sent to Mo could have sent it to you guys. So basically those questions will help you to learn some of the technical questions. But they will never ask you how much data we will store, how fast it will be processed, and these questions for sure they won't ask. They will be looking at what is the process you are doing and what is the process you would be building and how would you uh, deploy it. These are the most important things which they will ask. So guys, if you have any open questions, or if you are aware of, if you heard about any other questions or anything, let me know. Like you can ask me now, I can tell you. I will send these architecture things, you can go through once. And you can also look at Visio tool, how it be used, and how to build those architecture diagrams. That is also important basically. Sometimes in an interview they might ask, they might give you a scenario and they will tell 2-3 weeks, can you build a architecture for me and send it to me? That also happens. In those cases, try to reach more me, that time we can help in that. But basically you need to create it and you need to send them. But there you have to explain why did you select that architecture, why 3 tier, why 2 tier, why entire, why single tier, what is MVC architectures, these kind of things. Just do a quick Google and see what kind of architectures we have. Those all things. Okay,
Okay.
any other questions you can ask me, guys, because I just want to make sure that you have enough time to ask all the questions. So I'm making this 30 minutes available for you.
Please, if you don't mind, can you speak a little bit about the migration? Because I heard a lot of questions about migration because many companies try to move from on-prem to the cloud. So they ask, okay, give me one of your project that you've working based on migrations. What did you migrate, an application or whatever, or I don't know. So walk me through the process, how you do, what's the steps for migration, how you did that migration. So how should we answer those questions?
So yesterday, I guess we talked about on this. Why do we do migration and how to do migration? Yesterday class is about these specifically. I said why we need to select a serverless, why we are doing a migration, what is the reason we would be selecting which databases. All these things yesterday we talked about, and you need to have a adoption framework. That's the main important. What you have done migration, that's for sure. If you are, yeah, I have done some application applications migration or database migration. That's the thing we need to talk about. So yesterday class you are present, right? Yesterday we talked about all these things, and I have sent you some migration documents also in the group. So those documents will help, because this is a pretty thing. If I say one of the migration, it will not help you for sure. If I tell see, now also I talked about building an enterprise data lake. That is also a migration, which I spoke about how the data lake migration will be happen from a SAP system. From a SAP system, I'll collect the data. I will make sure that the raw data is collected into JSON format. I will store it into S3. From S3, I'm making sure that I want to ingest the data into my Snowflake. For that, I have built some Python programming where it will do extract, transform, and load the data into my Snowflake staging. From the Snowflake staging, so basically like if your user wants to connect, if your user wants to connect to the raw data, he will connect to my S3 data. Or else if he wants to connect, if he wants the data for reporting, he will connect to this uh, Snowflake layer where he can build the database, because he has a relational data over there. So it will work as a data warehouse, and this that is also on migration, which I have explained.
Okay, thank you.
And read those documents. Those documents will help.
Yeah. Quick question. Do those documents have all the information that we need for that we pretty much discussed this weekend? Does it touch on pretty much a little bit of all those topics? I kind of briefed through it, but I haven't gone through them in detail. I was just curious.
Yeah, it will have all the topics which I discussed and everything. But see, the only thing is, if you go through those documents, you can articulate. Basically, you can talk about. If someone asks about what are the best practices we need to consider about when doing a migration, you will have some points. I won't say exactly those questions would be there or something, but you can collect that information and you can use it in the interview. You can talk about all the best practices. You can talk about the migration frameworks. Not exactly pin to pen you would be saying the same framework. Yeah, the framework, as I mentioned before, planning to do a migration or anything, first of all you need to have a pre-checklist. You need to validate whether all the pre-checklists were done. Then what are the prerequisites, what are the post requisites, what kind of implementation, what is the mitigations, what are the risk mitigations, how to overcome this risk mitigations, how to deploy it, how to configure it. These are the important things, right? That's the migration plan. So this is how we plan it. So that should be more generic. Collect all the points, read all those documents,
Okay.
you'll get more information from that. Yeah.
Okay. And I have another question. So I remember when Mo was explaining about the data lake. I kind of like the way you explained it. And sometimes when you guys explain stuff, you guys kind of almost put it in layman terms, sort of a very simplified way for us to understand. So can we explain it that way in the interview, like the way we understand it? Like it shows understanding without having to use all these. I know the technical terms are important because you do say it's important that you say some of these terms, but at the same time, so sometimes I find it that I understand it one way in my head, and then when it comes time to explain it, I have to kind of get very technical. Then I kind of get confused in my head a little bit.
Yeah, basically add a term. I like when like the pro like you need to say like I can give an example to get it understand more a deep, more understanding way. I would use a layman terminology and give an example. That way they understand. So like right now
Okay.
someone asked a question whether we can use the data lake for the Fitbit instead of taking a complicated autonomous car or something. You can say like pretty we have seen that for Fitbits and these things they would be collecting the data. Fitbit would be collecting all the data that would be transforming into the S3. If that could be those kind of examples you can give, or else you can say talk about the sensor data of your home, or if you have any those kind of examples, definitely yeah you can use the layman terminology, but make sure that in the you use
Okay.
some of the terminology also at points when we only need to use
Yeah.
store,
Gotcha.
like ingesting, store, analyze, process. These kind of terms need to be there. Whether you are using
I
a
know that.
layman terminology also, make sure the particular terms. You don't say I push the data, I ingesting the data, storing the data, processing the data, analyzing the data, reporting the data. So these kind of terms are must you need. Okay.
Okay. All right. Thank you.
And I want to add, that's a good point. So basically, folks, what you need to do is we'll show you resources, but you need to find one or two user cases that you can explain. These are like good examples that Thera just provided, but you can look also online, and I think AWS provides some of these, and we'll try to send a link to some of these cases, and then just get one or two, and then study it well, so you can talk about this step by step how you did. What we just explained here is the process, like Thera's talked about the 3-layer development. So understand that concept and say, layer one, this is what I would do. Layer two, the business layer, this is how I will go about doing the business logic. And then layer three, this is how the presentation layer will show. When you start using those terminology, it's practice. It's reading up first on those documentation that he sent, so you kind of get your own gist of the terminology, right? And what you got to do, you got to find one or two user cases that you can comfortably talk about. And it's like an actor, like learning the script, but they know the different parts, the different role, and they can explain it. So once you pick one or two of those and you can explain it, and then you use those things we talked about in the first few sessions, where you're saying, okay, you start using, we use this once you plan, then we use Jira, then you start incorporating all those aspects. Let them see the picture that you understand from dealing with the customer, saying what does the customer want. You get the requirements. So how do you go about architecting it, and then how do you go about executing what has been architected, and then how you interact with the client. So you got to give that whole picture, but you got to tell it your own story. The only thing is the user case you're going to use will let them know you know exactly how to go through the process. So you got to pick a user case, one or two, and then you solidly understand it, how you did it, and you can explain step by step how you go about doing it. It's going to do two things. Number one, it's going to take up a lot of time in the interview. And then number two, it's going to show them that you understand what you're talking about. You understand the processes. And they're not going to have those follow-up questions that are going to trick you, because by how you explain it, you've given them that. So it takes a little bit of work, but that's what you guys are gonna work on, is getting these stories and doing all of these things, and then from there it's easier for you to explain it, right? And if you have to break it down in layman's terms to get your point across at times, it depends who you're talking to. If you're talking to somebody who doesn't like the first screening, you can break it down in an amount of times from like you teaching them. That way they know you know what you're talking about, right? But when you get to a technical point where the person you're talking to really like knows what they're doing, try to talk in their terms. So it's like communication, you talk to people based on the level they're in. The screening, you break it down layman's term if the person is not too knowledgeable, so they understand, you know how it is. So you become like a teacher. But when you meet with the technical folks, use the technical terms. Meet them where they are, so you know, so they know the terminology, the lingo. I don't know if that makes sense.
Yeah, that's the
Yes,
main
it
thing.
does.
Yeah. So see here, like this is one wonderful article. I can say, if you guys didn't understand, still you have a confusion of data lake architecture, demystifying data lake architecture. This is a wonderful document which I like mostly, and this document you read it and use these. Like make sure what you are reading in the document or something, those concepts you should use in your interviews. So you need to make sure that mostly this is a pretty common architecture in traditional data warehouse. Like basically, when you say the most common myths in all the organizations in on-premises, they used to have a lot of structured data sources, then used to extract, transform, structure and load and keep it in an enterprise data warehouse. Then they used to create data marts, OLAP for reporting, for presentation layer. For again, some other team comes again, they have to build the same thing, structure. It's a repeating process. So like when the user needs to connect to the raw data, they don't have a ability because these all are controlled by IT and they don't have that option. But in the new when you consider about these cloud architectures or something, they have a more free hand to do. They have a more free hands to do, because now the definition of data is like I talked about, 3 V's: variety, velocity, volume and veracity. When you have these kind of data, you might get the data from a sensors, from pictures, what kind of data, how you want to analyze. Then you need to have a single source of truth, where where you need to make sure that you need to have this data lake. So data lake is something where you can fish anywhere. So basically what you are doing is you are doing a plumbing work. You are making sure that you are you are making sure that you have a data lake, you created a data lake, and like the users can do their plumbing work. If they need to set up their plumbing work, like basically you have a well, okay, you have a well or something, you constructed a lake. From there, every team will have an architect. It's his responsibility to do a plumbing work. From the data lake, how he need to bring water, how he need to bring data into bedroom, how he needs to bring data into kitchen, how he needs to bring data into bathroom. For that, you need to do the data pipeline. So you have a single data lake and you are not creating water bottles and you are not sending. If you create water bottles and if you send it, it would be a difficult task. So that's the reason the concept of data lake will be there, the conceptual data lake structure. So this is what the conceptual. So unstructured or structured, see, you have a data cataloging, data security and governance. You can do data discovery, exploratory data analysis, predictive modeling, all on the raw data itself, not on the processed data. Got it? So this is the main thing. So if any user want to do data discovery, if any was to do a exploratory data analysis, predictive modeling or something, if you already transform the data, user cannot do that because they don't have a free hands to do predictive modeling. That's the reason we need to have a raw data store, which is called as data lake, enterprise data lake. Got it? Read this doc. It will help you a lot. You will understand what is analytical sandbox, cataloging, what is cataloging, what is governance and everything. This is one of the thing I like. So basically I would send this link in WhatsApp for sure for you guys. Read those docs. Definitely you need to read those docs. All the knowledge what we have till today, also most of the things we might have not done, but we have read the docs. That's the reason these knowledge were there. So the watch is batch processing, so these kind of terminology also you need to know. So what batch processing is, what processed data is, what real-time processing is there. Yeah, you have a pretty good ways. Read it. It's for Azure, but still it will work. You will understand it, what exactly happens in cloud. Okay. And this is one. And you can also see the Pradeep Menon's page in Data Central. This is also a good things. You will have a lot of documents in here. I'll send these links also. That will be helpful for you. Okay. Any other questions, guys?
Hey, sorry, before somebody asks a question, did you send me? You say you emailed me the document? I don't see it in my email.
You should see it. Basically, I sent it as a Google Doc. I shared it as a Google Doc.
Okay.
AWS. Yeah.
Okay.
Yeah.
And yeah, so again, any helpful links or anything like that, please put it in the form for them, and then what I would do, we'll try to compile it and put it in like a document that they can all have access to read. But folks, this is the part where you got to actually read, like you said. The documentation is there. The next few weeks is more you guys prepping, reading, and understanding how you're going to talk about this. And that's the main point of doing this. If you can just get that, get one or two user cases you understand, know how to talk the lingo, and then get past it, you will get jobs. But this is the part where we got to put that story together. So again, it's your last day, so ask questions. Since Tara is here.
I mean, this is just something that I'm dealing with personally, and I just want to put it out there. Um, I mean, whatever we just went over is very helpful because me personally, I'm still trying to get used to the words, the technical words. So, whatever we just cover, is very good. So, I mean, I just want to put it out there.
Thank you. Any other questions, guys? It's up to basically you can ask me the questions. We can discuss all the other important things. And,
Hey Tara, can we touch base on
yeah.
What kind of things they should include in LinkedIn? Because a lot of recruiters now are going to LinkedIn and they recruiting there. They're looking at people's profile. What?
I think these guys should not have LinkedIn right now. Basically, once they are good with everything, they can put out a LinkedIn profile. All those when they got when they get all the experience and everything, because then only the LinkedIn will helpful. Otherwise, you don't have a LinkedIn. Also, it's not a problem. You just say I don't use social networking sites. That's it. That's it. That will work basically. But when you want to put a profile in LinkedIn, make sure that you cannot remove that LinkedIn's or those profiles or anything. So that's one more. I think basically these guys might have a LinkedIn which was created earlier itself, right? And
Yeah, some of
use
them,
it
yeah.
from the points from the resume itself. Make sure to disable or block those resumes, block those LinkedIn profiles if your data is not appropriate or something, because easily they can find out basically your friends and everything. Having social networking sites is like giving up them key like most of the companies, they do profiling on this LinkedIn's also based on your friend list or something. They'll find out the things that also, that screening also will be difficult. That's the reason I won't say promoting the social networking sites, but definitely, but some companies might look at it, how you are communicating with, collaborating with other employees or something. That's also I would say both positive and negative on this, but for these guys, I don't suggest to have a LinkedIn profile for sure.
Okay. Yeah, Farmer,
Because
you going to ask a question?
Yeah, it was me. So my concern is when I look at the resume, I saw a lot of points that makes me like kind of confused a little bit. So Tara, is it okay like maybe to reduce some of them, like, or to do like, I know you said we can edit, but I'm just concerned whether some of them we can reduce it a little bit just to be
yeah,
comfortable.
if you feel you're not comfortable of anything, remove it. Basically, as I mentioned, those points would have greater visibility. That's the reason. Basically, I said your resume need to be screening. The screening need to happen for any position. Those points need to be there. So obviously, if you don't know those points, if you start removing those points, you might not get the calls. That's one thing you need to remember. So what I
So
would say is, rather than removing, just go and learn those. What are those topics? Just Google it. Find those more information on that. So at least to talk. They won't ask you to implement in front of them for sure. definitely they won't ask it. They would ask what it would be doing and how it would be doing. The information would be pretty enough.
That's a good point. So I know some of you look at it like scared. All of us went through that. When I first got in IT, when I saw my resume, the guy was talking about data guard, talking about rack. I didn't know any of that stuff. I just had done one of the main thing, but all I did was I read up enough. So they say if somebody asks me what is rack, I can just explain it. This is what rack does, right? If this is what is what a so just remember your resume is your script. Like Tara says, the first part is for it to be pulled so they can even call you. And then just be able to talk about it. You don't have to know all the tools. Once you get to the job, if you need to do certain things, you can go up and learn. Even till today, I'm doing some things that I've never done before. Like even on this migration I did some things I never migrated OBIE, but I had to learn it. I figured it out and learned it on the job to do what I need to do. So I would
And
not.
pretty one more thing,
Mhm.
one more thing I can add on here is when you don't know a thing. Let's say if you don't know about Jenkins, you need to tell that I haven't implemented this Jenkins, but I read about it. I know pretty sure what it is doing. I didn't get a chance to work on it in my previous company. You can say this line. If they ask a question, have you worked on Jenkins? If like guess the interviewer if you're asking a question, have you worked on Jenkins, did you implement this? If you feel that he would be asking questions, say I read about this Jenkins. I have done pretty exercises on my own, and I have created on my own, not in a project, to learn something, because in my last company I didn't get a chance to work with them, but pretty sure I know the concepts, how it was functioning and what it is doing. In the real time use case, I'm not sure how it can be used, but pretty sure I have done some lab exercises and these things that would uh, uh, that would stop him from going into deeper. So that's one thing which you can use it at times as for to save you from those questions.
Yeah. So and mind you too, one of the things you're gonna be doing is keep up with the technology. Again, reading a bit, understanding how it is. Try to put it
I think you're
in
muted.
a way. Oh, can you hear me? How about now?
Yes, we can hear you, Mo.
Okay. So I say just try to read up. Your resume is like your little story backline. So some of the things that are not there that you're not familiar with, just read up on it, and then you can be like, I'm familiar with it. I didn't use it, but and then always default to, you know what, I'm a fast learner. I believe I can learn. If sometimes they throw you questions that kind of get you off the rail, but it's natural when you get your resume for you to be scared. I know I can tell you guys I definitely was when I had mine. But now is a process where you learn it, you start to figure out some of those things, and in the next couple of weeks, just go through, read up, and brush up things, and then put it in your own words. Like if you read about something, try to put it in your own words how you would say it. And I employ everyone to get like a tape recorder or something where they can just record themselves answering like questions, and then listen to yourself how you're answering those questions, so you can get better at talking at stuff before you start taking interviews. But again, what I would say is once a week we'll be meeting together as a group. In the next, at least for the next month, we'll do once a week where we meet and then we discuss and plan and see how we can improve during the interview process. But you also got to be doing your own work on the back end. Does that make sense?
Yes.
It does more.
Okay, we're almost out of time. Any other questions? Farah, did you send me the notes from last week? Is that what's included in that Google Doc?
Yeah,
Okay.
it has all the questions, all the input points which I talked about. I mentioned all those points. We could go.
Okay. So I'll be distributing that later today.
Yeah,
I'm gonna
it's
be
not pretty formatted or something. Just look at those questions, read those questions. How maybe questions can be in that way. Some of the questions I don't have answers, but basically you can answer all of those. Yeah, I also quickly Googled something and picked some questions which I liked it. So some questions answers won't be there, But sure, make sure you write answers, you distribute between yourself. And if you don't know any questions, just post it on online, you will find everything. So the only thing why I'm doing this is that way you will Google it. If you Google it, you'll find the answers and you won't forget them. When you try to Google those answers and if you create them, then you won't forget those answers, and you will have a small discussion on that. Why this, why it is not that. That discussion has to be done. So basically I expect a discussion need to happen. So generally if you don't discuss, even in this session also, I expected it to be a more interactive thing, but it's only through the people has done it. When a person is discussing something like he is saying something, you should ask like why it is not this kind of thing will give you an edge. Like basically those points will help you, because basically we may know only 2 points, but the other 2 points which we collect from some other person, that will help. So usually that should happen. I don't know how you guys are preparing and these things. What is the best thing why I divided you is teams is also the main thing is the 5 members in a team, 5 topics. The other 5 members in the topic, 5 topics. The other 5 members in the team, 5 topics. Pick five topics for each team. Make sure that you transfer your knowledge between you. Have a session, do a whiteboarding, and present what you have read, what are the important points you feel. Yeah, share it. One person about EC2 instance, one person is about, one person about architecture. I think Fabrice, the like Kashmir, George, Mufti, Omar, these guys these guys have to talk about the architectures and these. Have a discussion, like do a whiteboarding session. If you can personally meet in a personally meet, that's a good thing to do. Definitely that will help a lot thing. You can present yourself how confidently you are presenting it. The whole thing you can present it in interviews also. If not, doing virtually also I would prefer it. But this kind of sessions has to happen. See, if you are not interacting with me, it's fine. If you are not asking me questions, if you are not doing a discussion with me, it's fine. But if you are not discussing with your fellow mates, that's a problem. That means you're not confident enough. Either it is right or wrong. They have a discussion between you guys and make sure that make all those points. What if you someone is saying something, make all the notes. That notes will be helpful for you. Okay, that's the main thing you guys have to do.
So what I recommend is what I'm also gonna be doing is you guys are still gonna be attending Saturdays if possible. Whoever can, you're gonna see Saturday. You can use the other conference room in the other office there. And while my current session is going on, you guys can go there and we'll get like a discussion. So we'll plan what you guys are gonna do the week. So I'll do one session online with you guys during the week, and then on the weekend, you guys, whoever can make it, should be able to come. Even if you can join virtually, you can also do that if you're not comfortable coming in. But you guys should meet and then, like Tara said, have a discussion and plan and go and get topics that you're working. So you're not just sitting there, but you're actually now in the process of talking it. And what's gonna happen is your confidence is gonna go up. You're gonna be more familiar with the topics, and you guys are gonna be asking each other questions. So you learn talking the language. And if you guys do that for like a month or so, you'll be able to like ace these interviews. I'm sure of that.
Yeah, and I think these guys basically I think the 4 or 5 guys which I mentioned these names, because see the reason is I didn't mention the other guys names, or that's these guys had left something like basically regarding the resume or the interactions what I had with these particular people during the inputs or updates for the resumes what they have done. They specifically told I'm good at this, I have learned this. So they are continuously not putting only concentration on AWS itself. They're saying I know Splunk, I know Tableau, I know I have done networking, I'm good with subnetting, I'm good with IP masking. Look, these points had made me remember those. So basically those guys know something which you guys might don't know. And the other thing what I would say is take some sessions. Make sure that uh, let's do a practice session like yourselves, present yourself, do one guy how to spin a AWS instance, how to create a VPC, do it from the scratch. One person in a 1 week, present it, the whole thing, setting up a EC2 instance or installing a Tableau on it, right? Or else setting up VPC and installing Informatica on it, or else setting up the EMR to collect some data from the S3 and to put it to make sure that it is available for all the users. You are spinning it. It will cost some money. It will cost some few bucks. Make sure that you allocate $500 or to $300, that I would use $300. Spin the machines, do the work in those classes, and then do it. That architecture also will remember, like basically what steps you are doing, you guys will remember. That kind of exercise need to happen when you do these AWS things or something. That's one thing I would suggest. Those exercises need to be done. You need to present yourself. What Mo has presented in the classes, you guys take and demonstrate it. So basically doing all those things, developing a website, putting a website, all these things you should do it. Then only it will help you guys. Any questions?
Well,
I have one more. I have one more question. So, sir, are you gonna send us any script that we may need? I mean, in the future, just to practice.
Script. What kind of script the humans?
Um, I mean, any script that we can use just to practice, like to put applications together.
Script for sure. I can't provide any scripts, but the thing is, I'll see you should, like, the basically what you did in labs, you have AWS dev tools to create it, instead of creating the same name or something. You can follow those steps and you can create your own instances. So that I'll see if I have any scripts or not, but I'll check and I'll say.
Okay.
I'm not pretty sure if I have
Okay.
any scripts available. Yeah.
Thank you.
okay. So any other questions? If not, what I would do, I will reach out to you guys. Let's see what would be a good day during the week to meet to have a session. With the exception of Wednesday, I can't do Wednesday. You guys know, obviously, no Wednesday. But what day during the week? Maybe let's say a Thursday. Either a Tuesday or Thursday. Let's pick one of those days where we can do like, even if it's a 2-hour session, it will be like our weekly interview prep and our sessions. So, and what we'll do is, maybe a couple of times. Yeah, go ahead.
No, sorry. My internet connection is weak, I guess. I thought nobody is talking. More continue. I just sent some links of GitHub for the person who has asked me whether we can get some scripts. AWS has some GitHub accounts in AWS Labs that I have sent you in basically in our WhatsApp group. So you will have some scripts over there. Basically look over their scripts and you can try to use those scripts, how to spin with the scripts and these things. So you have a basically this GitHub accounts templates also. You'll have cloud formation templates also you'll have available. I will send that link also. You can use that. Okay.
Thank you very much.
Yeah. So that's a good point. So what you need to do, let's we'll have those meetings, and then like Sarah suggests, sometimes and then Saturday, I encourage everyone who can make it on Saturday, at least for the next month, still come on Saturday as you guys are prepping and going through your resume. So we're gonna end it there. So what the assignment between now and I'll let you guys, we can discuss it in the forum as far as who wants to, when is a good day, either Tuesday or Thursday. Those are the days I'll suggest you guys pick. We can pick one of those days to do 2 hours in the evening, and then definitely on Saturdays, who can make it. If you can't make it, see if you can do it virtually. But I would suggest you guys come together at least for the 4 weeks while you guys are prepping and getting ready for the jobs as you're looking for work. But go through your resume, and then kind of the things you don't know, make notes of them, because you need to learn at least to talk about those. But I would not want you to, like Tara said, if you start taking things out, your resume may not get picked up when jobs are searching for a particular candidate. So it's a two-part game. Number one, your resume needs to be picked up so you can get the call. Number two, once you get the call, can you get through the first phone screening and then and talk about that? And usually what happens is you get like an HR person who calls you or something like that, and then you got to know who's talking to you in that first screening. If the person is not like an AWS person who doesn't know well, they're just asking questions, be like a teacher. Like I try to teach him what his tools are, okay? But if the person is technical, then you got to start throwing those technical terms and make sure that your communication has to go to the level of the person who's interviewing you. Does that make sense? But don't be scared. We'll work through it. Just like you guys were scared before we did these sessions, now you're not as scared. So we'll also work through it so you guys are okay. Okay?
Okay.
Quick one. Hello?
Yeah.
Okay.
Yeah, more for the Saturday. Can we select a time that doesn't like conflict with your time? Because some of us will still want to join that and have like a refresher. So can we select a time that's not
Yeah,
10?
if you guys want to do it in the office is open. I'm usually there till 4. So you guys can pick a time that you guys want to work on that. That's fine. Like I said, I'm flexible with you guys on that. So I'm usually in the office at least till 4 o'clock Saturdays, till 4, 5. If I need to push it to 5, I can do that. But you guys, we can have that discussion and see how it fits. I know some people still want to participate in the class again, but again, you are never going to be 100% ready. Let me tell you that right now. But you just keep working on your skills as you interview, and you're always going to be scared. Don't let that scare you though from learning and continue.
Yeah, if you have any questions or something, just mention in that group. If you have any interviews or something, just ping me. If I'm free or something, definitely we can have a discussion based on the job description. Personally, I feel that almost in this group are good. I expect like first there are 6 or 7 people who should focus more on the topics. Basically they are not pretty confident. They are saying that see, one thing what I think is you need to be confident on yourself. Basically when I'm doing this information collection also, I felt some of the things, 7 or around 7 people, they are quite not strongly sounding, like they are saying that I would try after 2 months. So I'm not at prepared, I'm still learning. So these, like, give it a shot. If you get a call, give it a shot. Whether it is successful or not, then we can think about it. But I'm pretty sure like 5-6 guys, they're pretty they're up to the mark. Like as I mentioned some names before, those guys have to give the shot from right now itself. Like as I mentioned, you can put a fake resume, like put a different resume, which is and you can do it. Or else make sure you go with 2 weeks preparation and start putting these resumes into the market. That will give you a good edge. Okay. And reach out to me if you have any questions or something. Definitely post in that group. We have a WhatsApp group. In that you can keep it. If you need something, guidance or something, basically you can personally contact me. But make sure that if my response was not faster enough or something, don't be upset. Basically, if I'm in work or something, I might respond very late. But if it is important, just leave a message that I have interview or something. I'll connect some other time and I'll just give you some inputs. Okay.
Okay. Thank you very much.
Okay, thank you. Thank you.
All right, thank you.
Thank you. Bye.
Yeah, thank you.
Thank you, Mo.
So much, Tara. Bye. Thank
Thank
you.
Bye.
you.
Bye.
All right, folks. Thanks. Thanks, Sarah.
Bye.
All right. Bye-bye.